Hello everyone, my name is Signolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, in this video we are going to be continuing with our lesson on the parabolic function or the quadratic function, and we will be looking at the third standard form of our quadratic functions. You will remember from the preceding videos that we looked at two standard forms. The first standard form that we looked at was y is equal to ax squared plus bx plus c, and we mentioned that the advantage that this standard form has over the other two standard forms is the fact that you can immediately tell what your y-intercept is there, which is c. Okay, so this is your y-intercept. Okay, and from the standard form you can immediately by inspection tell what your y-intercept is, and therefore you have an idea about where your graph cuts through the y-axis. Okay, the second standard form that we looked at was this form here. Y is equal to a, open bracket, x minus p, close bracket, all squared, plus q. Okay, and we noted in a preceding video, in the previous video, that the advantage of this standard form is that you know from inspection, by inspection, you can tell immediately what the coordinates of your turning point are. Okay, and we know that the coordinates of your turning point in this case are P and Q. Okay, where P is your X value and Q is your Y value. Okay, so by inspection you can immediately tell what your turning point coordinates are for the standard form, whereas you can't do that for your first standard form. Okay, so now we are going to be looking at a third standard form, and the third standard form is of the form y is equal to a, open bracket, x minus x1, close bracket, x minus x2. This is your third and last standard form for your quadratic functions or your parabolas. Okay, now let's go into a bit more detail with this standard form. Now, the standard form, I'm just going to rewrite it here, is a, open bracket, x minus x1, x minus x2, okay, close bracket. This is your standard form. Now, what is a? A is just a coefficient. Okay, it's just a constant. It's a coefficient of one of the brackets. It's just a constant number, right? And it represents a number. Okay, now x1 and x2 are also constants. Okay, they are constants, and they will, what those values are will give us an indication of a bit of important piece of information. Okay, so these are your x values and they are constant. Okay, so x values, and they are constants. Okay, they are constant values for a particular graph or particular parabola. I'm going to explain what that means now. Okay, now to explain this standard form further, you've got those numbers. You've got y is equal to a, x minus x1, and x minus x2. Okay, let's say before I actually paint a much more clear picture of why this standard form is important, let's use an example. Let's say we've got y in this standard form. We've got y is equal to whatever, 2, okay, x minus 2, x plus 3. It's just an example. Okay. And let's say we are asked to sketch this. Let's say we are asked to sketch this function, okay, with this equation. They ask us to sketch it. Remember what the steps for sketching are. The steps for sketching are, you find the x and y intercepts, right? You find your x and y intercepts. Okay, you find your x and y intercepts. I covered this in a previous video. Then after finding your x and y intercepts, you establish the shape or the direction of your graph. Establish the shape and direction of your graph. Establish shape and direction. Okay, you look at a previous video to see these steps. And then step number three is sketch. Okay, you sketch. Once you have all these pieces of information, you can sketch your graph. But you can follow a slightly different procedure depending on the type of standard form that you're looking at. But these three steps will work for any of the three standard forms. But you could find a quicker way of sketching these graphs if you use each of the three standard forms to their advantage. Okay, so let's go back to our example. Now our example is y is equal to, what is our example again? Our example is 2 minus 2 plus 3. We've got 2x minus 2, then x plus 3. How do we sketch that? Well, remember, step number 1 is to find your x and y intercept. Your x-intercept, okay, let's start with your y-intercept. What is your y-intercept? What is your y-intercept when x is equal to 0? Remember, your y-intercept is the value of your y when your x is equal to 0. Okay, so wherever you see an x, you're going to substitute it with 0, and then you're going to solve for y. So you've got 2. Then instead of x there, you're going to write 0. So 0 minus 2. Close bracket, there's another 0 there. Instead of that x, there's another x there. Instead of that x, you're going to write a 0 plus 3. Okay, then when you solve, you will get 2. 0 minus 2 is minus 2. Then 0 plus 3 is 3. Then 2 times minus 2 is minus 4. Then minus 4 times 3 is equal to minus 12. So your y-intercept is minus 12. This is the value at which your graph will pass through on your y-axis when you sketch this graph. Okay, that's your y-intercept. Now, what about your x-intercept? You know that to find your x-intercept, your y has got to be 0, right? So x-intercepts when y is equal to 0. So you just take that original equation, which is y is equal to 2, and then x minus 2, x plus 3. And wherever you have a y, there's your y there. Wherever you have a y, you're going to replace it with 0 because your x-intercepts are the values of x when y is equal to 0. So instead of y, you're going to write in 0 is equal to 2. And then you have x minus 2. Then you've got x plus 3. Okay. Now, you will notice that here you can immediately find the values of x. You can immediately find the values of x. Remember what the whole point, I explained this in detail in a previous video. But whenever you have something like this, an equation like this, right, a quadratic equation like this with 0 on one side, and you've got terms, factors that you multiply together to give you a 0, then the aim of this equation, the aim of the approach when you're solving this equation is to make one of the brackets equal to 0 and then solve. Okay, and make one of the brackets equal to 0 and then solve. Okay, solve one set of brackets at a time. Okay, so I'm going to start with this set, this pair here. So you're going to take that and you're going to say x minus 2 is equal to 0. You want the entire x minus 2 to be equal to 0 so that when you take this 0 and you multiply it with x plus 3, you are going to get 0, because anything multiplied by 0 is 0. Okay, and the left-hand side in this case is 0. So that's the entire reason why we are doing this, why we are taking what's inside the bracket and equating it to 0. So in this case, we know that x, okay, when the 2 goes to the other side, x is equal to 2. Okay, so that's one of your x-intercepts. Okay, now if I take the second pair of brackets and I say x plus 3 is equal to 0, then I know that I'm going to have x, then the 3 is going to go to the other side, it's going to change its sign, it's going to be negative, so x is equal to 3, minus 3. Right, so these are your x-intercepts when y is equal to 0. Right, and now you can establish the direction and shape of your graph. Remember what our equation is. Our equation is y is equal to 2x minus 2x plus 3. This is our equation. Now, this is a. What do we know about a? We know that if that value of a there, if a is less than 0, that means a is negative. And if a is negative, then a is sad. It has a frown. Okay, it's frowning. If a is greater than 0, then a is positive, and a is smiling. It has a smiley face. Okay, so in this case, 2 is positive. This is a positive 2, so a is greater than 0. So the shape of our graph will look like that. The shape and direction of our graph will be like that. Okay, so now you have all the 3 pieces of information that you need to sketch your parabola, so you can go ahead and sketch it. Now if you were to sketch that graph, remember to always label your axes, right? If you were to sketch that graph, you will remember that your y-intercept, let's have a look at it. It's not dependent on memory. Your y-intercept is minus 12. There's your y-intercept there. It's minus 12. Okay, we calculated it earlier on. So your y-intercept is minus 12. Your y-intercept is minus 12. Your x-intercepts, right, x1 and x2. Your x-intercepts are, we calculated them here in the previous page. Your x-intercepts are 2 and minus 3. 2 and minus 3. Right? Those are your x-intercepts, 2 and minus 3. So we're going to come back down here and then we're going to write those down. 2 and minus 3. So we've got positive 2. We've got minus 3. Okay, and then you've established that your graph is smiling, so it takes the shape of a smile. Okay, so we've got all those pieces of information that we need, so we can sketch. Where is minus 3 and where is 2? Say 1, 2 is here. Okay, 2 is there. Then minus 3, 1, 2. Let's say minus 3 is somewhere there. Okay, and then y is equal to minus 12. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Minus 12 is there. There's minus 12. So your graph, okay, let me use a different color. Your graph passes through that minus 12 there, because that's your y-axis. It passes through that minus 3. That's one of your x-intercepts. Y-intercept is minus 12, x-intercept is minus 3, x-intercept is positive 2. So your graph passes through all those points, and then you can just join your graph. Okay, it's a parabola, so make sure that we know that it's a smiley face, right? It's a smiley face, and this is your graph. Now, what is the whole point of us having that standard form that we started off with? Well, I want you to notice something. If we go back to our standard form is, go back to the very first page. Our standard form is this, right? This is our standard form. Our standard form is y is equal to a, open bracket, x minus x1, close bracket, open bracket, x minus x2. If you look at what x1 and x2 is, what was our problem? The equation that we were asked to sketch was y is equal to 2x minus 2, x plus 3. The x in what, if you look at this equation here, you will agree with me that these values correspond to each other. So this value corresponds to that value, and this value corresponds to that value. Okay, you will agree with me that those values correspond. And from the answer that we got, what are the x-intercepts? Our x-intercepts are 2 and minus 3. 2 and minus 3 are x-intercepts that we found. 2 and minus 3. So let me write them down. So x1 was 2 and x2 was minus 3. What do you notice about these values? Well, this value is that value. The magnitude is the same and the signs are reversed. So x1 is plus 2. What you have in the bracket there is minus 2, right? x2 is minus 3. What you have in the bracket there is minus 3. x2 is minus 3. What you have in the bracket there is plus 3, right? So what does this tell you? Well, it tells you that this standard form gives us the value. From inspection, we can immediately tell that the values of our x-intercepts, we can immediately tell what the values of our x-intercepts are from the standard form. Okay, so in other words, let me put it nicely in a nice little page of its own. In other words, this is what that standard form tells you. If you've got a standard form, y is equal to a, then you've got x minus x1, then you've got x minus x2. Okay, those values there are our x-intercepts. They are our x-intercepts of our quadratic function, but with the signs, with their signs reversed. Okay, with their signs reversed. So basically what I'm saying is that they have opposite signs. So if you have a negative here, one of your x-intercepts will have a positive. If you have a positive here or negative still, one of the other x-intercepts will have the opposite sign. Okay, so this is the advantage of this standard form. It gives us our x-intercepts from inspection, simply from inspection. Now, if I go back and talk about all the three different standard forms, again, remember, first standard form gives you the y-intercept, right? The second standard form gives you the turning points. The third standard form gives you the x-intercepts. Okay, so each one of these three standard forms have their own unique advantages, and each of the advantages is that each one gives you a piece of unique information that you can identify from visual inspection. Okay, so from visual inspection, you can immediately derive a bit of information about your quadratic function or your parabola. Okay, so now I'm just gonna write out a bunch of equations to hammer the point home. Let's say you've got this equation here. Y is equal to 2 open bracket x minus 20 x plus 10. You can immediately tell, if I asked you what are the x-intercepts, well, the x-intercepts, because you can tell from visual inspection, immediately you can tell what they are. You have minus 20 in here, right? You have minus 20, so one of your x-intercepts will be, x1 will be, if you've got a minus, then it will be positive. So it'll be positive, and then you keep the value 20. And then x2 will be, what is that sign there? That sign is positive, so you'll have a negative, the opposite sign, and then 10. And then these are your x-intercepts of your graph. Okay. And let's do another example. If you've got y is equal to x minus 3, then x plus 2. Well, you will be able to tell me immediately from visual inspection if I asked you to find the x-intercepts. If I asked you to find the x-intercepts, what you will be able to tell me is that x1 will be, that sign is negative there, that number is 3. So you take the opposite sign, that's going to be plus, then you take the number, that's 3. Okay, and then x2 is going to be, that sign is a plus there, and then that number there is a 2. So these are your x-intercepts. Okay, so if I were to ask you, okay, let me just give you a let me just say, if I were to ask you to sketch this graph very quickly and very roughly, illustratively, okay, let's say I ask you to sketch the following graph. Let's say you've got y is equal to minus x minus 6 x plus 7. Now I'll ask you to sketch this graph for me very quickly. Well, you will be able to tell me that this actually is one of your 3 standard forms. It's the 3rd standard form. So immediately you know what your x-intercepts are, right? x1 is equal to positive 6, right? And x2 is equal to negative 7. Okay, now you know that one of them is equal to positive 6, one of them is equal to 7. Now, your value of your a there, is minus 1, okay, because you've got a negative and then you've got a 1 there that is invisible. So since a is greater than, is less than 0, because a is negative 1, so it's less than 0, a is negative, so your graph takes on that shape there. It goes down like that, right? And if I were to ask you to sketch it very, very quickly, you would tell me the following. You would say, okay, so my graph has the x-intercepts at x1 is equal to 6. So 1, 2, 3, 4, 5, 6 is there. Then minus 7, let's say 1, 2, 3. Let's place them a little closer. 1, 2, 3, 4, 5, 6, 7. That's minus 7 and that's 6. Okay, and then what is the shape of your graph? The shape of your graph goes down like that. So you'll be able to tell me that your graph passes through that point and it passes through that point and it goes down like that. Okay, it goes down like that. Now, the information you have about this graph is incomplete because you don't know what the y-intercept is. The y-axis goes all the way up, and then your graph cuts your y-axis somewhere there. But if I were to ask you to sketch it very, very quickly and very, illustratively, this is what you would show me. And already, so you have an idea of what your graph looks like just by visual inspection, just by looking at the equation. Okay, so basically this is what this equation tells you. This is what the standard form tells you. It tells you that your x-intercepts are these 2 values, and it tells you the shape of your graph as well, so that you can quickly start deriving some information about it before you actually start sketching. So it helps to be able to see these things in your head when you're solving, so that you know the kinds of answers to expect. Okay, so you should be able to test yourself and to see if you're getting an answer that doesn't make sense. So, you should know the kind of answer that you are expecting to get from your calculations and whatever. And if you're getting something other than what you're expecting, which I hope is correct, then you know that you're doing something wrong. Maybe it's a calculation error, maybe it's a misunderstanding of a concept, something is being done wrong. Okay, so that's essentially it. That is the 3rd standard form, and that's how you interpret it. And that is how you would deal with it if you were to come across it. Okay, we will deal with more complex questions in separate videos, but this video is just dedicated to explaining the very, very basics of these forms, okay, and what they mean. Okay, so we will see you in the next video. Till next time. Lesson number 1, lesson number 1. Lesson number 1, lesson number 1.